Hi, we are coming to the difference equation. Difference equation is usually used for modeling or describing a discrete time system or digital system. And it is different from the differential equation. Now, maybe we just look from here. This is the xn, the input that we are actually looking at here. So this is a kind of what we call a summing junction here. Summing junction. So what you can see is from this particular point here, y of n is also here. Y of n is equal to x of n plus the point here, maybe k of n here. So we are not going to bother with this first. Now, first we can see that y of n is here, y of n is here. So because of that, so at this particular point is what we call yn minus 1 obtained by the kind of delay. I like to say that delay in digital systems usually obtained by using software or simply by the microcontroller. So it's pretty simple to obtain one delay and two delay, something like that. And the implementation is not the scope of this course, but it can be simply done. Now coming back here, yn minus 1 here. So after another delay, so we have yn minus 2 here. And we have multiplied this one by minus 3. So at this particular point, so we have minus 3 yn minus 1. Okay, so at this particular point here, so we have 2 yn minus 2. Now, so we come to another summing junction here. So it's pretty straightforward. So this one plus that one. Okay. Sorry about that. I noticed there's a little bit error in the diagram. The arrow shouldn't be here. The arrow should be here. Okay. Please correct it in your handout. Alright. So because of that, what we can see xn. So we've got xn plus this thing 2yn minus 2, and then plus this one minus 3yn minus 1. This is summing sum of all things together equals to yn. Okay, so we can just try to rearrange the equation. When we rearrange the equation, we will have just like this one. Rearrange that yn plus 3yn minus 1 minus 2yn minus 2 equal to xn. Right, this is the difference equation. We call it difference equations simply because this one plus this one and then minus that one is equal to the output. So everything is based on the difference between different kind of signal. That's why we call it difference equation. And we also like to say that this kind of digital system or discrete time system, it has system dynamics. What does it mean, system dynamics? System dynamics, just like things with changing magnitude. Now, what you can see is that my voice hasn't got much dynamics because some sort of problem with my vocal cord. Right, so my voice lack of dynamics, but your voice can have better dynamics. So system dynamics, that means the output can have a large variation. That's the dynamics. And you're also saying that this system is built from delay. That's the delay we are talking about. The gains, that's the gain we are talking about, minus 3 times and 2 times. Adder, we also have the adder. This is the adder. Now, another interesting thing is the memory. So what does it mean, memory? Memory, that means that the system output yn, the system output yn here has some kind of effect being affected by xn minus 1, xn minus 2, and xn minus 3. That is what it meant. It has a kind of memory, right? In this particular case here, what you can imagine that xn give you yn. Then if you're going to change that, change it into yn plus 1, then we change everything, become yn minus 2, yn minus 1 equal to xn minus 1. Then what you can see that the xn plus 1, the yn plus 1 is being affected by how the system output yn and also the previous input xn minus 1. So this is what it meant. It has a kind of memory effect. Now I like to use the finite impulse response digital filter to further strengthen what we said a while ago. Now there are two types of filter. One is the FIR filter, which I'm going to illustrate to you. Another one is the IR, infinite impulse response, which we are not going to talk about filter design, so we just skip it here. Okay. Now, coming from this particular digital diagram here, what we can see here, we have a xk here, then xk going in, multiplied by 5, fitting into this summing junction. So we have xk multiplied by 5xk, and then plus, then become yk. So we're expecting plus this one got one delay here, so this one become xk minus 1, so become plus minus 2, so we have minus 2. We have minus 2 xk minus 1. Similarly, this one becomes xk minus 2. Then this one is 3 over 2. So we have 3 over 2 xk minus 2. So we are talking about this point. Similarly, we have xk minus 3. Then minus 3. So we have minus 3 xk minus 3. Okay, then they all sum together equal to yk. Sum together equal to yk. So this is the difference equation, which is pretty simple and straightforward to obtain. No trick at all. Now we just come to finding the impulse response. So impulse response is, this is a filter here. Suppose if we are going to give the xk is an impulse, k0, 1. So how the output filter will respond? Okay, now then we just, how we are going to do it, we just substitute everything into the equation what we have obtained here. So because we are going to talk about the impulse response, xk or x0 is equal to 1 or equal to delta 0. This is what this is about. So we have y when k is equal to 0, when k is equal to 0. So we have y0 is equal to phi delta 0 minus 2 delta minus 1, then delta minus 2, and so on. These we don't need to bother because these are all equal to 0. Remind you that this is the impulse that we are talking about, k equal to 0. All other equal to 0 except k is equal to 0. So we're going to focus on so from the sense y0 is equal to h0 because the input is impulse, so we call this is an impulse response. We use h to represent it, is equal to 5. Similarly, when k is equal to 1, so we have y1 is equal to 5 delta 1 minus 2 delta 1 minus 1 is equal to 0 plus 3 over 2 delta minus 1 all are equal to 0. So we have y1 is equal to h1 is equal to minus 2. So similarly, we can substitute into another thing, then we can get h3 is equal to minus 3, then we go to k is equal to 4, then y4 is equal to 5 delta 4, that's equal to 0, minus 2 delta 3 also equal to 0, then something delta 2, then minus 3 delta 1, so 0, 0, no more. So we can see that, right, when h4, h5, and so on, they are all equal to 0. That is the reason why h4, h5, for k bigger than 4, they are all equal to 0. So what we can see is, for a system here, when we have a delta, when we have a delta 0, so what is the output? The output become the first one, h1 is equal to, the first one, h0 is equal to 5, then h1 is equal to minus 2, is minus 2, then h2 is equal to 3 over 2, sorry, something wrong, 3 over 2, and h4 is x0, 1, 2, h3 is equal to minus 3, then h4 is equal to 0, x5 is 0. So what we can see, the output getting such a dynamic. So this is what we call the dynamics output. We just give the input just something like that, then we have an output of something like that. Okay.